Hi, quick video here on chapter 2.2, derivatives of sine and cosine. So, here we go. The derivative with respect to x of sine of x is equal to cosine of x. Pretty straightforward. The derivative with respect to x of cosine is negative sine. Okay? So these trig functions are pretty easy to deal with. We're not changing any... they might have amplitude, they might have something with a period, but right now they're pretty basic, okay? So let's just look at a few examples that are fairly straightforward. If y is equal to 2 sine x, well then y prime, or the derivative, is equal to 2 cosine x. So we just substitute the 2 in. Not a lot more math involved with that. Okay? Example number 2. If y is equal to 6x squared plus cosine x, well, then y prime, we take the normal derivative of the 6x squared, we take our 2, again, remember the power rule, bring that down, multiply it by 6, we get 12, and then reduce the power by 1, and we get 12x. Now, because the derivative of cosine is negative sine, so we put negative sine of x, changed from cosine to negative sine. So the final product here is y prime is equal to 12x minus sine of x. All right, finally, example number 3. We have y equals cosine x minus pi over 3 sine x. All right? The derivative of cosine is negative sine. So that just takes it in place. Minus pi over 3 sine x, the derivative of that is pi over 3 cosine x. Now, where you might run into some challenges is watching your negatives, because if you do have a negative, and then I'm taking the derivative of cosine, and I get negative sine, you might have to do a sign change in there. So, for instance, let's say I have y is equal to cosine x minus pi over 3 cosine x. Okay? So here, y equals cosine x minus pi over 3 cosine of x. Well, y prime is going to equal negative sine of x. And then this that stays the same, but now this becomes negative pi over 3 sine of x. And so what you'll notice is that those two negatives become a positive, and so y prime is equal to negative sine of x plus pi over 3 sine of x. And there you go. Okay? Hope that helps. Enjoy. We'll do more of those practice problems in class. Hope you're having a great time. We'll talk to you soon.